so this is one of the problems from 1-3. Here's the graph, and it does help to hit the plus sign. And I think I helped somebody else with this problem today. She had a question about a MyMathLab problem. So we're going to use the graph and the equation of the function. The equation is given. Notice the equation is given. And this is the window in the calculator. It means -5 this way, +5 this way. The scale is 1. -70 this way, and +70 this way. It could be the scale. You didn't understand the scale. It's by tens on this one. -10, -20, -30, 40, 50, 60, 70. And this, so, and then you don't just guess it because they give you the equation. So you're going to use the calculator. So a function has a relative minimum at. So let's put this in the calculator. Use the graph. Well, we're going to use our calculator. Y equals, clear. We're going to put in 2x to the third minus 6x squared minus 18x plus 3. Then we can do, then we can go to our window. We can make our window the same as theirs. A -5 for the x min, x max is +5, x scale is 1, y min is -70, y max is +70, and we want to go by tens. The little tick marks will be every 10. We're just doing an extra problem in his graph. We're doing a MathLab problem. Okay, so I have it drawn here. Now we want to find where it has a relative maxima or maximum. That's up here. We're going to have to use the calculator because we really can't read from the graph the exact value. So we're going to use the calculator. Second, calculate, and we're going to find a maximum. Enter. We need a left bound, so we go to the left of that bump, and we are to the left of it, and I hit enter. Then it asks for a right bound. We go to the right of it, and hit enter. And then it says guess. We can guess that it's -1, or we could just hit enter. It probably is -1. You got that right.
Oh, no, it put it in there for me.
Oh, okay. Oh, sorry.
It gave me the right answer, but I didn't know how to get it.
Okay. It gives you, okay, so you can't get it from their graph. You can't read it off the graph. You have to put it in your calculator. And so you get -1 and 13. And it has a relative minimum down here. So you go second, calculate, number 3, minimum. Then you need a left bound for the minimum. So just go down here. So you're anywhere to the left of the minimum. Hit enter. That's the minimum. So now we have to move to the right of it. Just make sure you're to the right of it. Then you can hit enter. And you could guess a number like 3, or we could just hit enter. And it is actually 3, -51. The calculator approximates it. When you see 2.9999986, that means 3. Okay? So I think it would be hard to read on the graph that this was -51. So that was a hard problem. So
Well, it doesn't really give you anything. It might in the book, but
yeah, question help, did it tell you,
Not
give you an
much.
example?
It tried to, but it didn't really.
No, not really. Does it tell you to use the calculator? No.
No, that question help is not much help.
Oh, well, you could see that you think it's at where the relative maxima is at -4 on that graph. So you could take your calculator and put it in that function, see what -4 is at. But I think that's what they're going to do. They can read where the minima or maxima occurs, and then they're going to put that value in here and find it instead of how I did it graphically. So,
But just knowing what those numbers meant, that -5, 5, 1, 5.
oh
I
yeah,
didn't even know what that meant, so.
sure, okay.
I had no clue.
Do you know what it means now?
I do.
Good.
I do.
Good. So I think the book explains how to use a calculator, and also the MATLAB has a tutorial, but it helps to ask because I know it, but I generally wouldn't show that to you guys. All right, well. Back. Okay, section 1.4. So this is linear functions and slope. So data presented in a visual form as a set of points is called a scatter plot. A line that best fits the data points in a scatter plot is called a regression line. And when measuring the steepness of the line, we can find the slope m of the line. Slope compares the vertical change, rise, to the horizontal change, run, when moving from one fixed point to another along the line. So here's the definition of slope. And you should be familiar with that. There's the picture. We have 2 points. We can make a triangle out of it, find rise over run. That's where they get that formula. And a line with a positive slope increases, and a line with a negative slope decreases. A horizontal line is a constant function, has a slope of 0, and the slope of the vertical line is undefined. Okay, so here's some pictures. If you have a positive slope, it's increasing, the line rises, and you always look at graphs from left to right. If it's a negative slope, the line falls. And if it's 0 slope, the line's horizontal. And if it's undefined slope, the line is vertical. So we're going to find the slope of the line passing through each pair of points, or state that the slope is undefined, because you won't be able to find it if it's undefined. You just say it's undefined. So that's 4. Then indicate whether the line through the point rises, falls, is horizontal or vertical. Okay, so good math is to go ahead and write your formula down. Label your points as x1, y1, x2, y2. Remember they're ordered pairs, x comma y. And the formula is y2 minus y1 over x2 minus x1 is -2. Bring the minus sign over. Minus -4. All over 4 minus 6. And then we minus and negative, the same as positive. So -2 plus 4 is 2. And 4 minus 6 is -2. So you get a slope of -1. So the line It's negative slope, so the line falls. Okay, so that's finding slope when you have 2 points. So label your points again. Write down the formula carefully. I've seen people, forget, just don't write it down carefully. Forget that there's a minus sign there between the x's and the y's. Y2 is negative 1 minus y1 is negative 1. X2 is 3 minus 4. And then that's minus and negative is plus. Change. Okay. And minus 1 plus 1 is 0. And 0 over anything is 0, except over itself. So the slope is 0. So it's a horizontal line. So we have to make sure we answer all the questions asked too. Okay, so that's slope. Then we have the point slope form of the line. This is the point slope form of the line. It's for a non-vertical line. The equation for a vertical line, I have it on the next page or something, is x equals a constant. And for a horizontal line, the equation is y equals b, which is also a constant, but it's the y-intercept. Okay, that's a horizontal line, vertical line. But so we can find, if it's non-vertical, we can use this formula. If it's a horizontal line, n will be 0, and we'll be able to use the formula. X will cancel out, we'll have y equals y1. That's what you get. But anyway, this is the point slope form. You need to use this form. It's given to you on the formula sheet for the test. I give you 4 equations, but I don't tell you what it is. It's got a point and a slope, so it's a point slope form. So if I ask you to find something in point slope form, don't keep going. But this question says find it in point slope form with a slope of negative 5 that passes through negative 4, negative 2, y1. And then you're going to solve the equation for y. When you solve the equation for y, that is called, I'm just going down here, the slope-intercept form of the line y equals mx plus b. And then we have the general form on the next page where it's set to 0. And for some reason, my math lab's always asking you for general form. Just get it into this form and subtract the mx and the b. You can do it that way. You just have to get it equal to 0 for general form. Well, back up here, so we're going to get it into point slope form and then slope intercept form. We solve it for y, and that would be slope intercept form. So write down the formula. And then we're going to substitute y minus a negative 2 equals negative 5 times x minus a negative 4. Y plus 2 equals negative 5 times x plus 4. And this is simplified point slope form. Now we're going to distribute the minus 5 and solve for y. Minus 5x minus 20. Minus 5 times 4 is minus 20. And then we're going to subtract the 2. And we're going to get y equals minus 5x minus 22. So, if you have a slope and a point, you can find the equation of the line. You can find it in point slope, and you can find it in slope intercept. Alright, now we're going to, what if you have 2 points? Well, if you have 2 points, you can find their slope. Then you can just use 1 point in the slope, and you can find the equation of the line. So I do want you to use this formula rather than some of you learned a different way. Go ahead and use this formula because we're going to get point slope form and then we're going to get slope intercept form. So here's the 2 points, x1, y1, x2, y2. We're going to find the slope first, y2 minus y1, x2 minus x1 is -2 minus a -3. Be careful with your minus signs. Nope. What's wrong with that, guys? I'm getting tired. That's what's wrong with it. Let's start over. We have to have the 2 y's, not a y and an x. -2 minus 6. Good. And 3 minus a -3. Yeah. And then this is plus plus. So this is -8 over 6, and now that's right. Divide that by 2, minus 4/3. So the slope is minus 4/3. Okay? Now you're going to use the form y minus y1, and we'll just use that one. Doesn't matter. You can use either point, x minus x1. Y minus 6 equals minus 4/3 times x minus a -3. Yep, got it. This is going to be plus plus. So simplified point slope form is y minus 6 times 4/3 x times x plus 3. That's one answer. Okay, and then we're going to distribute, and it's just easiest to go ahead and distribute. If this didn't come out so nice, you can use your calculator to multiply fractions and get. In algebra, you want to leave things as improper fractions, but we can use our calculator when we distribute that. If you are bad with fractions, use your calculator for it. Anyway, you can distribute that. Y minus 6 equals minus 4/3 x. And when you take minus 4/3 times 3, the 3's cancel, and you get minus 4. It's not going to be always so nice, but, okay? But you can take it, right, put it in your calculator and get it too. And now we're going to add the 6, both sides. So y equals minus 4/3 x plus 2. And that's slope intercept. Slope intercept. Point slope. Okay? Okay? And that's the slope intercept, and if we change it to function notation, that's called a linear function because it's a line. And in case people didn't know all these big words, coefficient of x is the number in front of the x. That's the m. That's the slope. And the constant term, that's the term without a variable. This is the constant. which is the y-intercept. Is the y-intercept. And we'll use this form to easily graph the linear function. So we're going to show you how to graph that. Okay? So when you're graphing and it's in slope-intercept form, you plot the point containing the y-intercept first. And you're going to plot that on the y-axis. This is the point 0b. Then you're going to obtain a second point using the slope, m. You're going to write m as a fraction and use rise over run. You're going to start at the y-intercept and go up and over or down and left, down and over. And then you can draw the line with a straight edge. Okay, so give the slope and the y-intercept. So the slope is minus 2/5. It's one answer. The y-intercept is 0.6. It's 6, and when you put in 0, you get 6. That's it. I want the ordered pair for the y-intercept. And so when we're doing the slope, we can put the negative sign, negative 2/5 is the same as negative 2 over 5, is the same as 2 over negative 5. So if we write it like this is rise over run. We can go down to right 5. But if we move the negative sign down here, we can go up to left 5. Both of those are right, are correct. Okay? So we start at the y-intercept. Graph 0.6, you go to the origin, you go left to right 0, and up 6. There it is. Now you can go down 2 and right 5, or you can go up 2 and left 5. And then you connect it with straight line. I think I will get my straight edge. Okay, in my math lab, you'll only have to graph one of those points. I just wanted to make sure you knew that you can switch the minus sign around and graph it either way. Okay? All right, equations of horizontal and vertical lines. I already went through that. A horizontal line. And you need to know these. Is y equals b, where b is the y-intercept, and the slope of a horizontal line is 0. A vertical line is given by the form x equals a constant, say a, where a is the x-intercept of the line, and the slope of a vertical line is undefined. And then we have the general form of the equation of a line. AX plus BY plus C equals 0. So if you get into slope-intercept form, just subtract this stuff and move it over. Or it doesn't have to be. Y can have a coefficient, so you can leave it with numbers in front of it, but general form. If you have a problem with that, just click Ask My Instructor before the weekend, and I'll have a chance to let you know. I'll post it in Shobi under My Math Lab Test 1 questions. fact, there may be something posted already in my MATLAB test 1 questions from a previous semester. So, so these are the forms of the equation. General form, MATLAB does ask for that. Just set it to 0. Get the terms all on the left. All right, and then we have a word problem. And then section 1.5 is just 2 pages, but so I'm kind of getting tired, so I'm just going to give you. So this is a problem where here it's already worked out. Hey, how about that? They want the life expectancy of females. That's the lighter gray. So it's hard to read those, so I wrote them as a table. And they said to make a scatter plot for the years after 1960, the number of birth years after 1960, and Y is going to be female life expectancy. And this is a scatter plot. I made an axis, I wrote a title, axis titles, and I made it go by tens, and the last number was at 44, so, and not 50. And then it said on part B to draw a line through the 2 points that show female life expectancies. So in statistics, you would actually put those points in the calculator, and the calculator would give you the best regression line. For this class, we're just saying, hey, these 2 points look like they form a pretty good line representing this function. So it's not the regression line that you get with your calculator. We're going to make a regression line using these 2 points. So we get 2 points, x1, y1, x2, y2 then, and then we're going to write a linear function, e of x, that models that. So we're going to, it's just a word problem, and I'm not going to make you draw a scatter plot on the test, though. But you may have a word problem where you have to identify 2 points and find the equation of the line. You get 2 points, you can find the slope, then it's said to round it to 2 decimal places. Otherwise, we would have left it as a 6. And then, so, we've got to solve this to find the equation. This is part B continued. Y minus y1 equals m times x minus x1. And we can just use this first one. So y minus 74.7 equals 0.17, because they said to round the slope to 2 decimal places, times x minus 10. And they want you to solve it for y, so you can write it in terms of, in function notation, in terms of e of x for life expectancy. Function notation, we're going to use e of x instead of y at the end. So we have to solve it for y. So we're going to distribute this .17x minus 1.7, and then we're going to add 74.7 to both sides. So y equals 0.17x plus 73, I believe. Okay. So we found the slope. They told us the 2 points to use. We found the slope, just like we did the last problem. Now we're finding the equation. Now they want you to write it in function notation as e of x equals 0.17x plus 73. Now the last part says, use the function in part B to project the life expectancy of American women born in 2020. Well, remember in this graph, X equals 0 represents the year 1960. So the year 2020 2020 minus 1960, we can't just put in 2020 for X. So that is 60, right? So X is 60, so we're going to do E of 60, this is part C, equals 0.17 times 60 plus 73. And we're going to use our calculator. So we bring the calculator up. Point 17 times 60 plus 73. 83.2. And that's in years. So the life expectancy of a woman, I don't know, I can't do this now. In 2020 is projected to be $83.2 years. So you want to write a sentence. Okay, we'll get the calculator out of the way. So you won't have a problem where you have to come up, draw a scatter plot, but you will have a word problem where you have to come up with the equation and maybe make a prediction. Okay. All right, and that is section 1.4. Hooray. Are we tired yet?
Yep. Do you have section 1.5 on integrity already?
Yes. So it's only 2 pages. So we're going to do it. Let's see. It's parallel and perpendicular lines. The part that gets a little tricky is people struggle a little bit with average rate of change when they get to that. So you guys know about perpendicular and parallel lines already? We can fill in the blanks really fast. Lines that parallel. And if 2 non-vertical lines are parallel, then they have the same slope. If they have the same slope, that means they're parallel. Okay? And 2 distinct vertical lines, both with undefined slope, because vertical lines don't have slope. They're still parallel, though. Vertical lines, 2 vertical lines, as long as they're not the same line, they're parallel. Okay? All right. And here's what we'll do. This will go a lot faster. I mean, we've been working these problems over and over and over again. The only thing is, I'll work this part, is if you got the y plus 5x equals 4. The integrity didn't have it this way because it's an old integrity. But I changed this because I wanted to show you, and MATLAB does this, they don't give it to you in y equals mx plus b form. We want to find the equation of a line that goes through -2, -7, and is parallel to the line whose equation is y plus 5x equals 4. So you don't read the slope here, you have to get it into y equals mx plus b form first. Y equals minus 5x plus 4, so m is minus 5. So that's the difference, is I went ahead and changed that one more step, and then you're just going to use y minus y1 equals m times x minus x1. You've got a point, you've got a slope. You're going to use the point slope form. And when you do all that, here's what you get. It's not, we've been doing this like how many times already? So this is what you get. You plug those in, you change the signs. Here's the point slope form. Solve for y, and that's what you get. And you can try that. You get minus 5x minus 17 for slope intercept. But I made this a little harder. I want you to realize it has to be an mx plus b form. Okay, so the fill-ins, if two lines intersect at a right angle, they're perpendicular. A line is perpendicular to another line if its slope is a negative reciprocal. So reciprocal means you flip the fraction or take 1 over it. Or you could say it's the opposite reciprocal. So with reciprocal, you're going to flip the fraction or take 1 over the number. Negative or opposite means you're going to change its sign. So perpendicular, if two non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of their slopes is -1, then the lines are perpendicular. And then if you have a horizontal line, you know, horizontal and vertical lines are perpendicular. That's what this is saying. Okay? You have a horizontal line has a slope of 0, is perpendicular to a vertical line, having an undefined slope. So if you have, there we go. And this is, these, oh, I guess I don't have the filled in notes posted yet. I scanned them to post them, and then my drive that I copied them to, well, my computer won't read it. But I'm all right. I can scan them again. I can post these. So if two lines are perpendicular, if we want to find the equation of a line passing through a point and is perpendicular to this line, this is in y equals mx plus b. So m1 is a third. So you're going to flip it and get 3 and take the opposite sign, and you get -3. So the new slope, because it's perpendicular, is going to be -3. And you just use this point, and you do the stuff we've been doing, solving for y. This is slope intercept. And on the next page, I'll go ahead and write again. I know. You guys are writing it down anyway, aren't you? So this is what we've already done. It's just that if we're told, we need to remember if something's perpendicular. So if two lines are perpendicular, then M1 equals -1 over M2. Yeah, I just made a perpendicular symbol. If they're perpendicular, M1 we knit the opposite of 1 over M2. That's what opposite reciprocal means. Or if you would multiply these two slopes together, you're going to get -1. So, did you finish writing that? The people that wanted to write that out? Do you have questions? I know it. Just got worn out. Okay, I got the answers right here, let's just post them. Do you have questions? Okay. All right, well, let me do the next page. So, slope is, this is it, we're almost done. Slope is defined as the ratio of a change in y to a corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of change of the dependent variable, that's y, per unit change in the independent variable, that's x. So if the graph of a function is not a straight line, the average rate of change between any 2 points is the slope of the line containing the 2 points. Here's a picture. This line is called the secant line. So we got 2 points, but they're just written in function notation. Remember, x1, f of x1, that's just the same as y1, except it just specifies that this is y2. So it's just 2 points. So average rate of change is just slope, but it's slope for a function that's not a line. So the slope between any 2 points. The average rate of change, this is just a slope of change of f, function f, from x1 to x2 is this. And this is just another, this is given to you on the formula sheet. It is how we find average rate of change. But it is just slope. It's slope. But it's the slope of the straight line between the 2 points. Okay, so the average rate of change of these functions down here from x1 equals 3 to 6, this is not a straight line. And I drew it, okay, here's a picture of it. I brought it up on my calculator. It looks like this. It looks like it's a parabola. This is f of x. And we want to go, this is 1, 1, 2, so 3 is out here, and believe it or not, 4, 5, 6, 6 is out here. So we might be off the page if I were to draw that. But anyway, we're pretend that we're going from here to here. I drew it different. It's way up there. It's going to be really much. That's not a very good picture, but the 2 points, the slope between the points where x is 3 and x is 6, this could be the average rate of change. So here's the equation, f of x2 minus f of x1 divided by x2 minus x1. So we have x1 and x2, we have f of x. Let's find f of x2. x2 is just equal to 6. That's f of 6. So here I'm covering 1.1 or 1.2 where we plugged in 6 for x. everywhere you have an X, you put in 6. So that's 36 minus 12 is 24. And then f of x1, we need that for this formula, is f of 3 is 3 squared minus 2 times 3 is 9 minus 6 is 3. Okay, so if I plug those in the formula, we have 24 minus 3 divided by 6 minus 3. And so that's 21 divided by 3 is 7. The average rate of change is 7. And you know, this slope is supposed to be like that. But, okay, so between 3 and 6, we've got a slope of 7 on this parabola. Okay, that's the average rate of change between 3 and 6. The next one is the square root function, a little easier to draw. Square root function. And let's say this is 9 and this is 16. So here we have it. So the slope of the straight line through 9 and 16 is your average rate of change. So we're going to find f of x2. We just plug in, that's f of 16. We plug in 16 for x, we're taking the square root of 16, is 4. And f of x1 is f of 9 is the square root of 9 is 3. Now we can take the average rate of change is f of x2 minus f of x1 divided by x2 minus x1 is 4 minus 3 over 16 minus 9 is 1/7. So the slope of this line is 1/7. And the last thing is for physics, the average velocity. We'll just fill these in. It works the same way. In physics, we have a position function, s, and here's what it looks like. Instead of y here, we have an s, and we have time. And so if you threw an object and wanted to find the average velocity from this time to this time, you use that formula. And it's using function notation, s of t1 and s of t2. Okay, so same thing, it's the average velocity. But I think there's some my stat lab questions on it, but I'm not testing you on that. And that is it. And have a great night. Drive carefully. You know, when you get here this late at night, you can park in the passenger parking. And if you're uncomfortable walking, if you park out by the library or way back somewhere, you can call Kansas Police and have them drive you there or escort you. But if you're arriving after 5 o'clock, I think it is, you're part of the back of the bus.
I revised the first 45 cents, so these will be the.
Okay. do Friday. You don't have to turn it over to me. Write me a comment and Jody does everything else.
Because I already printed it out, filled it out, so.
Okay.
Because I sent one to you on show view, it was the first one that was due, but I revised it since then.
Okay, all right, thank you.